Hey guys, what we're going to look at today is the surface area of a rectangular prism. Now, a rectangular prism is just a 3D rectangle, right? We looked at those during the last lecture. So I've got 4 examples up on the board. All of them are labeled with a length, width, and height. I just want you to be aware for this class, a lot of people are very particular about what they use as their length, width, and height. I'm going to let you know what my preferences are, just so for future reference we're all set. Length, I always feel like, is the horizontal distance on the base of your shape. So wherever your shape touches the ground, I'm looking at the length of that side, right on the bottom. Okay, so length is the horizontal distance on the ground. For the width, I feel like width is from front to back. That is from the side that's closest to you to the side that's farther away from you. So I just want to make sure you're clear with my definitions. And height, you can imagine, is from top to bottom. So again, that's just what I use. You don't have to use those measurements at all. If you're on a test or a quiz and you label length, width, and height, I'm going to know what numbers you're using, so it's not a problem. I just want you to be aware for what I'm looking at. So I've got length is the horizontal, height is the vertical, width is front to back. Okay? As we're looking at these shapes, I hope you can see that they're made up of unit cubes, so it should be relatively easy for you to see the length, width, and height. I'm just counting the distance using the cubes as my unit. What we're going to look at is the nets of these rectangular prisms when they're unfolded. And I talked to a few of you about this today, about how the net of a shape is almost what it looks like when it's smushed, right? It's almost what it looks like when you open it all up and you pull out all the tabs and you have this flat shape. So the dotted lines that I inserted, those are kind of the creases. That's where you would fold the shape in order to get a 3-dimensional object. So we've got this 2-dimensional image of a flattened shape. Now, something that we haven't talked about yet is surface area. Surface area is the area around the shape. Okay, so think about this just a moment. When you flatten the shape, you flatten all the sides out. What you're getting, what you're looking at, is the surface area, because when you fold it back up, you're getting the area of all the surfaces, the sum of all these surfaces, okay? And just for those of you who may have blinked or forgot, area is equal to length times width, and it represents a flat space, a surface of a table or a piece of the wall or an area that you're going to tile or carpet, right? It's just a 2-dimensional space. When I'm looking at my rectangular prisms, I'm going to try and figure out the surface area. And I'm going to see if there's a pattern with regards to my length, width, and height. So what I have here is my net, and my net is made up of a length and a width, a length and a width and a width, and then I've got all these heights. And my heights are also lined up with lots of widths. Now I could go in and label all those spaces, but clearly just by looking at my shape I can figure it out. So I've got a front and a back of my box. I've got the left side and I've got the right side. And I've got the top and the bottom. And I've got to find the area of all of these things. For the front and the back of my box, my area can be expressed as the length times the height, because I've got 1 unit across the bottom, 1 unit vertically, and that's the surface of the front of my box. On the left side and the right side, I've got 1 unit, which is the height, times my width, because I go 6 units back. And for the top of the bottom of the box, I've got 1 unit of length multiplied by my width. Those are my dimensions. For each of these little formulas here, I've got to account twice because both the front and the back have these same dimensions. Both the left and the right have these dimensions, and both the tops and the bottoms have these dimensions. So if I look at all these pieces, this kind of categorizes my information for me. And I've got all the values that I need. I've got length is 1, width is 6, height is 1. So length 1, width 6, height 1. And I'm just going to make these substitutions. So for the front and the back of my box, the surface area is 1 times 1 times 2. It's my length times my width times, it's my length times my height times 2 because I have two surfaces. And that gives me 2. For the left and the right side, I've got the height, which is 1, times the width, which is 6, times 2 for two surfaces, gives me an area of 12. And whenever you have an area, it's 12 square units. So I'm going to write my units, and I'm going to put the square symbol. This just tells me that it's not 2 as in the number 2, it's 2 as in the area 2. Top and bottom of my box are length, which is 1, times width, which is 6, times my two surfaces. And that's going to give me, again, 12 square units. Okay? In order to find the total surface area, I need to add these values. I need to find the sum. So I've got 12 plus 12 plus 2. My surface area for this box is 26 square units. Now, this is a pretty straightforward concept, so I'm going to do one more quick example, and then I'm going to give you a quick flash of the next two and see if you could do them on your own. So length, width, height. I'm all set here. If I use the same formula as I did last time, I'm going to look at the front and the back of the box, the left and the right, and the top and the bottom. For the front and the back of the box, I have a height of 1 and a length of 3. So 1 times 3 times my two surfaces. Left and right side, again, height of 1, width of 3 times my two surfaces. And for the top and the bottom, I have a length of 3 times a width of 3 times my two surfaces. I'm going to find all these numbers. 1 times 3 times 2 is 6. 1 times 3 times 2 is 6. 3 times 3 times 2 is 18. I find the sum of that, and I have got 40 units squared. So, like I said, I want you to take a look at both of these examples. I've got a new shape right here. You can screenshot it or jot it down while you're pausing. And this one as well. And you can work on them in your notes on your own. This is not a complex idea. As soon as you realize that there's a pattern here, you've got to find the area of each side of the shape. And then you're going to take the sum of that. Okay, think about it like unfolding a cereal box or any kind of box that you've seen. And this is the kind of activity that we're going to do on Wednesday of this week. So make sure you're getting this concept down, do a couple practice problems, and you should be good to go. Thanks, guys. Have a good weekend.